Well, good evening, everybody. Welcome to GeoNight 2026. We're joining tonight with hundreds of other activities around the world. And this national event tonight, our Australian GeoNight event, is supported by the Royal Society of Victoria, University of Wollongong, the Royal Geographical Society of Queensland, the Royal Geographical Society of South Australia, Monash University Publishing, and Geography Victoria. My name is Ian Rutherford. I'm the president of Geography Victoria, and I'd just like to acknowledge the traditional owners of the many lands that we're all joining on tonight across Australia. So could you please ask questions tonight with the Q&A button at the bottom of the screen? And I would like to introduce our host for tonight, who is Rob Gell, who is the patron of Geography Victoria and also the president of the Royal Society of Victoria. Rob will introduce our speaker and curate the questions. Thank you, Rob.
Many thanks, Ian. It's a pleasure to be with everyone tonight. It's fun to have nights with geographers. We are very, very important thinkers, and I will enjoy being part of Sarah's presentation tonight and the questions that we have. May I introduce also a couple of our guest geographers. Firstly, with you, Giselle Pickering. Giselle is the Vice President of the Royal Geographical Society of Queensland. Now that we're post-Easter, we're all on Eastern Standard Time together. Still on Central Standard Time is Rod Shearing. Rod is a former president of the Royal Geographical Society of South Australia and very much involved in the RGS of South Australia's map collection currently. Now, Giselle and Rod will form a bit of a panel with me after Sarah's presentation to interrogate her on what she's spoken about. So welcome to Giselle and Rod. And now also may I introduce Associate Professor Sarah Hamylton. Sarah is a world-leading coastal geographer and Director of the Spatial Analysis Laboratory at the University of Wollongong and former President of the Australian Coral Reef Society. Dr. Hamylton has more than 20 years' experience mapping marine environments from the Red Sea to the Indian Ocean and the South Pacific via the Great Barrier Reef. In doing so, Sarah demonstrates that maps are more than just tools for analysis, that they tell powerful stories about places and people. Sarah's work translates complex spatial data into easy-to-understand visual stories highlighting our connection to the coast and the urgent issues caused by global warming. Now, her spatial stories have helped shape many decisions about marine protected areas and coastal management, and she's going to share some of those stories with us tonight. She's published more than 100 scientific papers and several books on coastlines and mapping. Now, she has a new book published in February this year by Monash University Publishing. It's called Plotting Oceans, Stories of Powerful Maps and Their Makers. So welcome, Sarah, and welcome to GeoNight 2026. It's good to have a coastal person presenting tonight. There's a lot that we don't know about coastal landscape, both above and below sea level. Don't you agree?
Absolutely. Yes. Thanks very much, Rob, for that kind and thoughtful introduction.
Yeah, maps are very good. I actually pulled from my library tonight. You'll maybe be familiar with this book, The Map That Changed the World, a book by Simon Winchester about, his nickname was William Strata Smith. And his maps started about 1815, gave birth to the science of geology. So perhaps plotting the oceans might have the same impact at some stage. We don't know. We'll wait and see. I'll let you take it away now. We'll look forward to your presentation and then we'll come back with questions. And as Ian said, everyone online, put your questions in the Q&A and I'll sort of collate those as we go and we'll be able to present them to Sarah in a panel afterwards. Welcome, Sarah, again. Over to you.
Thank you. Thanks for having me. Thank you to Ian for the invitation and
Here we are. All good.
Great. Okay. Well, I'd also like to begin by acknowledging the traditional owners of the land I'm speaking from, which is the Wadi Wadi people of the Dharawal Nation, otherwise known as Wollongong, about an hour south of Sydney. Okay, I shall just jump in and get talking about maps, which is probably what everybody would like to do. So I first got into mapping in my early 20s. I was working as a volunteer on a conservation project in Fiji. I was finishing up an environmental science degree and I had to do a work-based learning placement, and I really didn't want to spend my summer working in an office. So I decided to earn some money and paid for myself to go and be a volunteer on a coral reef conservation project. And it was a very formative experience for me when I was in my early 20s. I learned to dive. I did lots of diving. This is in the Mamanuca group, for anybody who knows Fiji, to the west of Nadi. A big area, lots of reefs. The Fijian Ministry of Tourism wanted to set up marine protected areas there. And so our remit was to do dives in teams and make notes about what we were seeing underwater. I also learned about satellites and satellite remote sensing, and we started making these really detailed maps of the reef systems there. And the idea was that you can't conserve something if you don't know what's there. So we were mapping the coral reef habitat. But not only were we mapping landscapes, but we were using those maps in sort of local coastal management decision-making meetings. So there was a very big meeting of the local chiefs whilst I was there. It's called a Takina Y meeting. And the local chief, a guy called Ratu Seva, had come over to visit us the day before this meeting and said, well, what have you got for us in terms of your maps of the reef systems? And it just so happened that I'd been in Nadi the previous week giving a presentation, and I had some map posters, and so I sort of put them out on the table in front of us, and I said, well, you know, we've been diving these areas, and these reefs look like they're really thriving at the moment. There's a lot of fish swimming around them, a lot of much smaller critters in among the cracks when you get down there and dive among them. And they would be good to conserve. If you conserve those reefs, then there'd be good spillover fish to the neighbouring reefs that people can still fish. And he was interested in that question really because there'd been a local dignitary had died, and it's customary in Fiji to set up a tambu area, a no fishing area, which is always a controversial job as well because people like their fishing. So he had to come up with an idea of where they should set up this no fishing area. And basically the next day at this big Takina Y meeting, I was sort of sitting there at the edge of this circle, and Ratu Seva had our maps out and he was waving them around, and people weren't necessarily pleased about the reefs that he was suggesting that they stop fishing because of this dignitary dying. But with the maps, I saw that he really used them as a way to communicate effectively his decisions about what to look after and how that would influence the neighbouring reefs. So really that was the first time I really learned about the power that maps have. And in particular, having been a map maker over the last, decade and a half, maybe 2 decades now actually, I noticed there are these internal and external dimensions to the power that maps have, and I've written them out there. So the internal power is really to do with the design of a map. How does it influence the way that somebody looks at it? How does that influence what people think about landscapes? What gets put into a map, what gets left out, what colour schemes are used, how are certain features emphasised, and equally how are things de-emphasised. And then there's also the external power of maps. So this is realised by patrons of cartography. Normally people don't make maps in a vacuum. There's a reason that someone's making a map. A real estate agent might make a map of your property to try and sell it and make a big profit. And so maps do a lot of work in broader society to influence decisions. So I've been a coastal map maker, yes, for quite a long time now. Let's just say quite a long time. Can't remember if it's 2 decades. And I found that I've been able to combine a whole bunch of activities that never get boring. So sailing, diving, flying drones, making spatial models, doing spatial statistics. It sounds a bit nerdy, but for people who are interested in viewing the world through a geographic lens, it's a really neat way of understanding phenomena. And really, in doing that, I've learned that maps really reflect the questions we ask, the values we hold, and the futures we imagine about the natural world. And in fact, we were talking about a map library and a map collection just 5 or 10 minutes ago between us before we started the presentation. And I've sat in quite a few map libraries, and I've sort of examined collections of maps that have been archived over the ages and learned that they have a lot more to tell us than about the configurations of landscapes of the past. They can tell us about ourselves. And if you view a chronological series of maps side by side, what that allows us to do is to trace our changing relationship with the world and our understanding of ourselves within it. And that's essentially what I'm going to try and do to you tonight by telling you 5 stories in a row that are chronological stories of people who've made maps and how they've influenced our understanding of the world. So there's a series of maps there that really reflect our changing methods and motivations for map making. So we're going from what essentially started as the purview of religious people making maps that had a lot of biblical symbology in them, moving through eras of things like colonial empires and people having this map it and own it philosophy, moving again on from an age of discovery and exploration to collecting data in order to understand places. That's a map in the lower left-hand corner there by Alexander von Humboldt, very famous map of a mountain where he took all sorts of instruments up with him in order to map these phenomena across a gradient of elevation. We've got the moonrise image there, a very famous image. We've got some new famous images coming into play now of different views of the moon and the earth. And then that lower right hand side we've got satellite images. That's the first overall satellite image mosaic of the full earth. But the first map that I wanted to talk about in terms of telling the story was one put together by 26-year-old Charles Darwin. So not many people know that he was actually on the Beagle voyage as the geologist, and he had been tasked with understanding how the world's coral reefs form over time. So he was trying to solve something that back then was called the coral reef problem, and he was seeking to understand how atolls form. This was an age when coral reefs and atolls were thought of as mortal dangers. Okay, so they would send these big oceanic voyages out, and sometimes they would lose thousands of lives if big ships were wrecked on reefs. They were trying to understand questions like, if you managed to plot a safe route through somewhere like the Torres Strait one year, which is a big maze of reefs, could you go through via the same route the following year, or would it have completely changed? Charles Darwin came up with his theory of coral reef formation basically halfway across the Pacific before he'd ever even seen a reef. And his theory basically posited a couple of things. One was that the world's reefs have formed on top of very slowly subsiding volcanoes. So you can see in that diagram on the left. Can you see my cursor? Yeah, so we can see here we've got reefs, fringing reefs forming around a peaky island. And then as the peak of that volcanic island subsides and goes down, that reef gets a bit further away from the coastline. It becomes a barrier reef. And over time, and this is geological time, so we're talking hundreds of thousands of years here, so slowly as to be imperceptible to us. But the top of that volcano will go under the surface of the water, but the reef will keep on growing, so you end up with these big rings of coral, and they tend to be positioned across the centre of the world's oceans. So not only did he say that the reefs form on top of subsiding volcanoes, but actually he arranged them in a sequence. So fringing reefs over time would transform into barrier reefs, which in turn would transform into atolls. Now, at the time, the technology of the day wasn't up to drilling into a coral reef to see if it was underlain by a volcano. So the evidence that he came up with to support his theory of reef formation was a map. He basically went back to England and spent a few years drawing on his remarkable social network to collate, if you like, all of the maps of the then venerable oceanic explorers. And what he did was he classified all of the reefs of the world that had been mapped by these ocean explorers into whether or not they were fringing reefs, barrier reefs, or atolls. And when he did that at the global level, the main argument, which is a very geographical argument that was supporting his theory of reef formation, was that you never see these different types of reefs intermingled. These different reefs are formed by different movements of the Earth's crust underneath them, and if you're looking at a barrier reef or a fringing reef, if you're looking at a barrier reef or an atoll, generally the Earth's crust is going down. So he coloured up on his map barrier reefs and atolls to be blue. Atolls were dark blue and fringing reefs were light blue. Atolls were dark blue, barrier reefs were light blue. And then, in contrast, fringing reefs were red. And so he found as soon as he did that on his global map, there were obvious patterns to the arrangement of the world's coral reefs. And so that lent quite a lot of credibility to his theory. Much later on in the 1950s, the Americans did a big drilling program to the Marshall Islands and found that, I think they went about 800 meters down. They drilled and found that those atolls are actually underlain by volcanic islands. So it remains the best account of reef formation today. And essentially, at a time when not much was known in terms of global maps, Darwin put forward what became a very well-known theory about coral reef formation, but broadly in geographic terms, he drew attention to the fact that the world isn't randomly structured. It's actually structured by processes, and that is something that we're often able to see in maps. And it raises the question, if we're looking at maps today, what other insights can we gain from them? The second story takes place in Antarctica. It actually takes place along the Antarctic Peninsula. So we've got the continent of Antarctica here, we've got the Antarctic Peninsula, and it points upwards like a pointy finger towards the downward pointing tip of South America. Okay, so Hubert Wilkins was quite a sort of a swashbuckling pilot, and he took a flight from the northern tip of the Antarctic Peninsula all the way down, and then he turned around and he came back again. Here you can see some old grainy black and white photos that he took on that flight. There he is with his flying partner, a guy called Ben Ilson. This flight took place in 1928. This was a time when if you mapped places in international law, you were able to claim them as your own. And in fact, the Antarctic Peninsula was the site of competing territorial claims between the British, the Chileans and the Argentinians. Okay, so they all had quite active mapping campaigns going on. Step into the frame Hubert Wilkins, an Australian pilot who had defied death when his plane plummeted out of the sky during an air race. But he was basically setting out, well, one, he'd been asked by the British to drop flags and claim the peninsula as he flew along it. But two, he was trying to answer a very basic question: was the peninsula attached to the continent or not? Was it a free-floating island? So he flew down it, turned around and flew back, and his answer was, it was a free-floating island. This is a very early example of something called remote sensing. You're sensing something remotely and mapping it from afar. Hubert Wilkins was actually wrong. He mistook frozen glaciers over a rocky underlying basement for free-flowing water. So he thought they weren't connected when in fact they were. And this turned out to be a really inconvenient mistake for a later expedition called the British Graham Land expedition that came down about 5 years later. And this expedition was about 16 men, dogs, motor sledges, 2 small aircraft, a few fishing boats, a 106-foot long fishing schooner, and they basically sledged thousands of kilometres down the peninsula with the idea of cutting across to the other side of the peninsula and sledging back. But they found when they got there, it was quite a high rocky outcrop that was covered by glaciers. So a fundamental problem that lies at the heart of a lot of mapping is that if you're doing it from afar, and these days we map with things like drones and satellite imagery, how can you be sure that what you think you're mapping is actually what you're mapping? Okay, story number 3, Marie Tharp. Marie Tharp was one of the first people to map the ocean floors. At a time when they thought they were rather flat and boring, she found her maps revealed essentially that they're covered in exciting things like mountains, canyons, valleys, and in particular of excitement, she drew attention to the existence of these mid-ocean ridges across all of the world's oceans. The first one that she mapped was the Mid-Atlantic Ocean ridge that you can see there. Of particular importance, in the middle of these ridges, they found there to be rift valleys, and she mapped those, and that essentially lent some very heavy weight to what was at the time deemed quite a controversial theory, which is that of plate tectonics and continental drift. So at the time they knew that the Earth was expanding and they didn't know the mechanism that was underpinning that. And somebody called Alfred Wegener earlier on, back in 1912, had proposed that all of the Earth's continents looked like they fitted together like jigsaw pieces in a puzzle, and perhaps there had been previously one big supercontinent that had broken up and then these plates were drifting apart. That was viewed as scientific heresy at the time, but Marie Tharp's maps led to an overall sort of turning of the tide in terms of scientific opinion. She worked with a guy you can see on the right hand side there called Bruce Heason. He was a well-known geologist at the time. I should also say that Marie Tharp was a woman working in a research institute, a place called Lamont Doherty Earth Observatory, which is part of Columbia University in northern New York. Because she was a woman, she wasn't allowed on ocean-going voyages. So her job essentially was to collate all of the soundings data and make the first maps of the ocean floor, or some of the first maps of the ocean floor. So sounding data, for those of you who don't know, is basically all of these dots, and each dot relates to a place where an oceanic vessel has beamed down a sound pulse, and it's bounced off the ocean floor and come back and been detected by the same sensor that's generally attached to the hull of a boat. Because we know how fast sound can move in the water, we can work out the time difference between when the pulse went out and when it was detected reflecting back, so we can work out how far away the ocean floor is from the hull of the boat. I've written there Marie Tharp's intuition for ocean depths. Mapping the ocean floor from soundings data is kind of like mapping a soccer pitch based on information from beneath the player's boots. There are a lot of gaps that need to be filled in, and there's a lot of guesswork that goes on. Marie Tharp had great intuition for that. These days, there are things like spatial statistics. You can stick those soundings points into GIS software, run an interpolation algorithm on them, and it's all automated for you. Those gaps will get filled in. Marie Tharp also worked, which was quite novel for the time, with an artist, a guy called Heinrich Buran. She'd been introduced to him through National Geographic, and together they put together these physiographic diagrams. They're almost like you're viewing the features of the ocean floors on the oblique, so sort of from the side rather than viewing straight down from above. And so that over the course of about 7 years working together, they did each of the ocean basins, and that came together and was published by the National Geographic. And when I was in Washington a few years back, I went and visited Marie Tharp. Actually, when she died, she left all of the contents of her house to the State Library, the Library of Congress in Washington, D.C. And so I went and I visited her map collection, and she'd got all of the maps that sort of laid the foundations for this world ocean floor panorama, and some of them were absolutely huge, and she'd plotted out by hand these thousands and thousands of soundings data points. But within the archives, I also found a letter to Marie Tharp by National Geographic in which they'd collated some of the feedback from readers of National Geographic about this map. And I wanted to read some of the quotes because they make me giggle, because they're from people who are very, very passionate about maps. The Atlantic Ocean floor map in June's issue has left me elated. I've been thinking about it for days. Somebody else says, my whole life I have hoped for a relief map of the ocean floor. Our Bible Centre is thrilled with the Atlantic Ocean map. It really is our special love. This is truly fascinating. I sat and stared at it for hours. An old couple here. We were awed with the beauty and mystery of it. Our grandchildren simply must have copies. And finally, my favourite, this is the most exciting thing I have ever seen. So a lot of love there for maps. All right. Story number 4. David Stoddart's battle to save Aldabra Atoll. So this is a story about conservation. So mapping something that's very remote in order to protect it. So the isolated wilderness of Aldabra Atoll is in the West Indian Ocean. So it's just offshore of East Africa, north of Madagascar. And David Stoddart was a well-known coastal geographer, and he had a reputation for landing on very isolated slips of land in the oceans and mapping them very quickly. So he caught a ride to Aldabra on a container ship, and he was immediately taken with how undisturbed and remarkably unique it was. So essentially, when he got off the ship, he said it was almost like stepping into the land of the dinosaurs, because it was absolutely covered in giant tortoises. So in the late 1960s, David Stoddart drew the world's attention to what became known as the Aldabra Affair. So the British Ministry of Defence had paired up with the Parliament and the House of Lords, and they wanted to basically build a remote military airbase, and they had earmarked a few remote atolls in the Indian Ocean to do so. So David landed on Aldabra, and he basically ran around mapping it as quickly as he could. He first visited in 1966 and said it was one of the most remarkable islands on Earth. There were thousands of giant tortoises grazing the tortoise turf and drinking from freshwater pools, and many colonies of seabirds and things. And so he quickly mapped it and drew the world's attention to it, and he started to advocate for Aldabra Atoll. And he started sort of waving the flag in the Royal Society, and saying, we can't build a military airbase here. That will spell ecological disaster for this place. And he started advocating for it in the UK government, in the House of Commons, and really he revisited several times. They did an airborne mapping campaign, which you can see on the right-hand side there, the flight lines and the aerial photography, which they turned into habitat maps for these giant tortoises. And essentially, I think it was in 1967, the UK government suddenly turned around and said, okay, we've given up plans for Aldabra. So it became a real win for conservation. And in fact, Aldabra was made a World Heritage Site in 1982. Okay, so the final story I want to finish up on is the work of Terry Hughes. So Terry Hughes was a marine biologist working out of James Cook University up in Townsville. And in 2015 to 2016, and then again the following summer, 2016 to 2017, he knew that there were going to be these mass coral bleaching events on the Great Barrier Reef. So coral bleaching essentially happens to reefs when sea surface temperatures get very high for an extended period. And so he basically knew that there was cumulative heat stress going on for the corals, and so he decided to spend 8 days flying up and down the 2,300 kilometre length of the Great Barrier Reef and assigning each of the reefs a bleaching score. So they started to turn white, and he really drew the world's attention to this phenomenon of mass coral bleaching at a time when it was a real political inconvenience for the government that were in power. He didn't do it on his own. He set up something called the National Coral Bleaching Task Force, and that was a network of Australian, largely collaborators, research scientists, and also students. They had people in the water diving and also surveying the reefs from close up, and they surveyed 260 reefs underwater. So rushing about on boats, accessing the reef through research stations and things. He made this map on the right-hand side that became very well known, was tweeted internationally, became known as the traffic light map, because up in the north that's where the heaviest levels of bleaching were, and really that got a lot of coverage internationally. And this was at a time when Australia was really feeling increasing impacts of climate change. So there were things like bushfires, and particularly the government of the day, the Liberal government, had an environment minister called Greg Hunt, who jumped in a plane and went out from Cairns to Lizard Island and came back to the airport and held his own media conference saying, oh no, there's not much bleaching going on the Great Barrier Reef, it's all fine. Terry Hughes also used his maps as digital data sets. So this is a series of very high-end research papers in journals like Science and Nature, in which they really started to untangle some of the spatial patterns of bleaching to better understand why it works. And at the centre of a lot of those maps, of those research papers, are the maps. So one example here on the right-hand side, we've got the spatial footprint of coral bleaching here. with red being lots of bleaching and green being not too much. And that's the spatial footprint of the sea surface temperatures. So a real geographical viewpoint on how those two things tally up and are related. So their groups made spatial models to tie those two things together. And of course, bleaching has gone on to be a very regular occurring phenomenon for the Great Barrier Reef. And there's now an ongoing mapping campaign. There are people in the air every summer pretty much now when mass coral bleaching occurs. All right, so just finishing up. I've got this quote that I've sort of pulled out of the conclusion of the book, and really I think of it as a fence-sitting quote in the sense that I am a coastal map maker, and like I said at the start, I spend a lot of time sailing, diving, flying drones, and making spatial models. And really, I get very excited by advances in technology for map making and the opportunities that they bring for us to make maps and better understand the world. But I do combine that with more of a critical approach of understanding the power that maps have, particularly when they've got this overlay of technical authority with them. When you're sort of making maps with satellite images and applying nerdy spatial algorithms and things, there's quite advanced science going on that enables you to make statements about the world. So bringing those two perspectives into what I like to call a provocative tension with one another, and essentially a way of having my cake and eating it. So I like using cartographic technology. I find map making exciting as an opportunity to understand the world through a geographic lens, and I think that opportunity to engage in the thoughtful production of maps is really enhanced when I think about the power that those maps take into broader society, and therefore I'm careful and open and transparent about the design choices I make and why I'm making that map in the first place. And that, I think, is where I'll leave it, and hopefully we can bounce off into a broader collective discussion.
Thank you very much, Sarah. Now, I'm hoping everyone can still hear me. My Wi-Fi has dropped out on my computer at home, so I'm now on my phone. So I hope that worked. Can you hear me okay, Sarah?
It's fine, Rob. We can hear you and see you well.
Okay, good. Sarah, I'm interested. Talk to us a little bit about your book. It's as much about map makers as maps. What is it that makes map makers special? What do they, and include yourself in this, but this is a special understanding about the value of pictorially or otherwise displaying data, and it's a special skill that geographers have. Talk to us a little bit about your thoughts on map makers in general.
Yeah, well, map making for me has been it's a way to proceed with making diagrams of the world for somebody who was never very good at art, actually. And so I've always enjoyed using things like satellite images as my canvas, if you like, and then applying algorithms to them. I think map making, maps sit alongside other kind of pictorial tools that scientists use, things like graphs, tables, to convey a message about something. Often, it's an empirical message. It's the product of gathering measurements out in the field and gathering data and then presenting them. For me, map making, I think I'm just somebody who's gone through life and gathered all of the fun bits and combined them into a cocktail that tastes good for me, if you like. So for me, I love doing coastal field work. I get a real kick out of making spatial models. I enjoy looking at maps and seeing patterns across landscapes and thinking to myself, that pattern looks that way because it's structured by this process. How can I write a model that expresses that basic understanding of the world? And often they're very simple models, but there's a real beauty in doing that.
Yeah, I think, and it's your preferred way of interpreting data and making it available. It's a very valuable skill. I'll let Rod and Giselle chime in whilst I have a look. This could be a little bit more difficult given that I'm on my phone about looking for the questions that are coming through in the chat. Rod or Giselle, do you have a question for Sarah?
Yeah, I have something that perhaps ties in quite nicely to that. So throughout your book, you talk a lot. There's a real feeling of the sense of connection to place that you have in the stories that you tell of your fieldwork. I'm curious about how you go about enacting your work in the field. Do you always have a fieldwork component to your research? Obviously, there are lots of really fantastically powerful remote sensing tools available to us, and you've also mentioned that you're particularly keen on the spatial statistics and the insights that those sorts of tools could provide. What's your kind of methodology? How do you usually go about working about the field component and the technical component of it and integrating those together in a way that works for you?
Yeah, absolutely. I try as much as I can to get out into the field. I consider it one of the most enjoyable parts of my job, but I also think that if you view a map as an expression of your understanding of a place, then that understanding is fundamentally reliant on, or at least influenced by, inhabiting that place. So I really do love to get out into whatever I'm mapping and see it and touch it and smell it and have experiences there. And I do think that those experiences find their ways into the maps that I make.
So there's a question, this all sort of follows together. I don't know where Lauren's from, but she's got a couple of questions here. Firstly about, and Rod, you might care to chime in here. Lauren's 8-year-old daughter loves maps and wants to know about a career in cartography. That might be, you both might talk about that. Lauren's got a concern, and many of us too, about the use of AI. And some of the things I do, I know that AI can be used for good. How do you validate your models nowadays? I mean, a bit of trust involved. How do you go about just making sure they're all right? And how much do you use AI in that process?
Look, I'll just let you into a bit of a secret. We've been using AI to establish a model catalogue of maps, and I've got to say, it's pretty impressive. There's a lot more information you can quickly gather through AI than you would ever do with human observation. It's just amazing. And this has only just come to light over the last couple of weeks while we've had a specialist programmer show us how this can be done.
What about Sarah, Lauren's question about the validation? Or, you'll use AI no doubt to validate, but also you need to make sure that the systems themselves, the models you're generating, are trustworthy.
Well, look, in my view, maps have always been a bit hit and miss. You look at a map and you think, gee, that's very good and very well done. But you often think, how accurate is it? And quite often, over a period of time, inaccuracies do come to the fore. And this is to do with, as Sarah's picked up in her book, the evolution of the map. Cartographers go through a series of evolution, I think, as they go from one map to another. And this is not new. I mean, this has been going on ever since the information was kept in the medieval scriptoriums. And people that travelled the world in those days, like 12th and 13th, 14th century, came back to the scriptorium and to the monks and said, had this town, had this bay, and so on. So maps have been evolving for years. But nowadays, the technology that we've got available, the GPS and the satellite stuff, is just so spot on, so spot on.
What are your thoughts, Sarah?
Well, a map is only a model of reality, and so inherently there's the intricate complexities of the natural world that you have to reduce by, putting a number of classes into a legend, for instance. There are numerical ways that you can try to quantify the accuracy of a map. With my students last week, we were mapping the vegetation on an island, and I went out to the island and took 100 photographs, and I had a GPS in one hand. No, I didn't. I just did it with my smartphone, actually. What am I talking about? And so we were able to plot the location of 100 different photographs, and then we literally, for those 100 photographs, compared what the photograph said the vegetation was and what we'd mapped it as. And then you express overall accuracy as of my 100 photographs, 80 they agreed with what the map said. Therefore, my map is 80% accurate. There are various metrics.
I think that ties in really nicely with your point on being transparent and being intentional about the ways that you're going about your map making. You're presenting the information about how, well, first of all, you're checking the accuracy of your models and then presenting that for the readers so that they have that information along with what you're presenting them to make up their own opinion about what they're reading and what that means for them, right?
Yeah, absolutely. I mean, going back to this idea of the internal and the external power of maps. The external power, the work that maps do in society, also speaks about their reliability, but in a different way. It's about why was somebody motivated to make that map in the first place, and what's the message that they wanted to convey with it. So, for instance, a real estate agent making a map of somebody's house might want to emphasize certain features of the house over others, and so that's a kind of a component of reliability that sits outside more of a scientific, how reliable is this map, how useful is it at depicting particular features.
Sarah, David Arthur's asking, do you work at all with Mike Roman from DETSI in Queensland, who's working in wetlands? He uses Globe as a basic mapping tool that unites landscape stories. Do you know him, or you have
it's a name I know. Yeah, I think I'm in a research group with him. Yeah, with various colleagues.
And back to Lauren, she's got a very inquisitive young family she's raising, obviously. Her son wants to know whether you put, there's something that he uses, trap streets. He wants to know whether you put fingerprints in your maps. Do you hide information in your maps?
No, I don't. I should do, though. That sounds like an exciting thing to do. Normally I'm in too much of a rush to move on to the next thing, but I should pause and put a fingerprint in.
Yeah, you need to. Well, even if you go back to Wilkie, you can own the map. I don't know. I don't know how that's very interesting. Taking hiding data. I mean, that's been done before in lots of things, I guess.
Well, Marie Tharp used to, if they didn't know, if there were big gaps on the map and they had no soundings data, she would just put a sea monster in there.
Really? Yeah. Like the old religious maps, you put all sorts of information in there.
Sarah,
interesting.
I was just pretty impressed with the work that Marie Tharp did.
Yeah.
It was just amazing, all that compilation of data to produce a picture of what the bottom of the ocean was.
Yeah, I was I mean, one of the little tools that I use, in some research that I'm doing with a guy about biofilms of all things, I was wondering whether you could actually take Marie Tharp's data and get AI to generate a video for you, explain what you did and how you did it and how it works. So it'd be fascinating. But they're some of the most beautiful maps that I think we've seen. Some of that stuff that explains to people visually that it's not just about us on the above sea level. It's really a dynamic planet. It's a extraordinary use of the tool. Do we have any other questions coming through? Here we are. Rob has had a visit recently to the United Kingdom's Hydrographic Office in Taunton and became aware of the extraordinary collection of maritime charts and maps held there. And he's wondering whether there's an Australian library or institution that has acquired digital or physical copies of those maps, and perhaps where can they be accessed from Australia?
It's not something I know the answer to. I could so the main places that have big map collections, Geoscience Australia holds a lot of spatial data, and then we've got our own hydrographic offices. What else is there? The National Library down in Canberra has got a lot of aerial photography.
What sort of mapping does our, for example, would the Royal Australian Navy have? How do they? I mean, even going back to Darwin and the problem with big ships and coral reefs, navies must have, and we used to have admiralty charts. So the navies must be being kept up to date. We were just chatting earlier for everyone. There's been a new island discovered in the Weddell Sea. It's about as big as the White House. It's just come up in the news feeds tonight. So I mean, there's stuff out there that navies need to know about. How do they? They must have access to the sort of information that Rob's asking about.
I'm not sure, to be honest with you. I know that at the state level, there's a lot of things like coastal LiDAR, but when you get out into oceanic waters, I imagine it's the hydrographic officers again.
Yeah, of each nation, but they must collaborate somehow.
Rob, could I ask a question?
Yeah, go in.
So, Sarah, I think the example you gave of Darwin's maps it's incredible that he was able to produce a global map of reefs just by talking to colleagues. And then the Marie Tharp one, which is another global map. Now, if you read Nature and Science these days, they are full of global synthesis data sets. And, the distribution of rivers, the distribution of wetlands, estuaries, all these things across the planet. Now, everybody you talk to who looks at those maps, who knows anything about it, says, oh, that's rubbish. I just don't even believe those global syntheses. Yet they're extremely common and powerful. Have you got any comments on this explosion of global maps?
Well, I suppose maybe it's to do with the time that we're in terms of the evolution of generating data from remote sensing technology, which I suppose first came up in the 1960s, 1970s, but people only started using satellite images regularly to map, for Earth observation much later. I would say it's more like the 1990s, 2000s. And moving on from that is this transition of the ways that we use and are able to access global data. And it just one of my specialisms is coral reefs, as you might have guessed, and we've sort of gone through these ages of, okay, well, we had Darwin's was the first, and then the United Nations Environment Programme World Conservation Monitoring Centre put together another global map of coral reefs that was done largely through aerial photography. That would have been made available largely after the Second World War. And then beyond that, there was another generational step forward when there was the Landsat Millennium Coral Reef Archive. So Landsat was quite low, quite coarse resolution in terms of satellite images. You couldn't see a lot of detail, but global coverage. They were able to mosaic together all of the Landsat images that covered the world's coral reefs. And now we have a global Allen Coral Atlas of coral reefs that's been generated through AI, through image recognition techniques. So there, I suppose that it's the moving forward of the technology. And then also, I think there are trends in scientific communities, aren't there? So people are probably cottoning on to the fact that if you do a study that's global in scope, you might get it up into Nature and get a pat on the back from your head of school or whatever department you're working in.
Very, very true.
I've been able to switch back, so just give me a second whilst I go back and find the chat.
I've got a question to slip in there.
Yeah, go ahead, please, Giselle.
There's a bunch of fascinating stories that you present in your book, Sarah. Are there any that, just didn't quite make the cut, but still hold a bit of a special place in your heart?
I would have liked to have done more. So wrapped around those stories some of my own anecdotes and things. And I begin the book talking about walking the Five Islands, which is just off of Port Kembla, which is just south of where I am, with an Aboriginal elder, a woman called Auntie Carol Speechley. And there's a really nice kind of dreaming story of these islands that relates quite well to a mountain that our university is just in the foothills of. And there are some really lovely parallels as to the Aboriginal understanding of how the islands formed, and how the geologists, who are actually some of the early geologists working in the School of Earth Sciences that I'm now in, understand it to have formed also through volcanic activity along the coastline. I would have liked to have, I guess, expanded that one out a bit and made it another story within the list. But there are so many stories of mapping. I mean, I'm sure you guys have got your own personal stories of people who mapped things in the world and really fundamentally changed our understanding of it and our relationship with it.
I can tell a story about it's really Indigenous engagement. My very first Institute of Australian Geographers conference, and it's back in the 1970s, and we were young geomorphologists presenting in quantitative geography. And at the end of the program, on about the second or third day at the Institute of Marine Science, there was a paper by an archaeologist on the evolution of the Lake Eacham and Lake Barine volcanic lakes on the Atherton tableland. And we were saying, what's an archaeologist know about the evolution of volcanic lakes? And he actually had spoken to the Indige mob up there, and they said, well, no, grandfathers told us they watched the volcanoes erupt and block the streams and form the lakes. And that time component is such an important thing in understanding of evolution of landscapes and reefs, as you've explained, Darwin's work. I think we haven't learned enough of Indigenous knowledge. It'll be very interesting to you could spend a lifetime understanding Indigenous mapping and how Aborigines got from one place to another, and what landscape, what did they notice in landscapes that enabled them to do that? It's a very interesting field.
We could probably learn a lot, couldn't we?
We could learn a lot. It's a very interesting discussion about. I had fellows of the Royal Society of Victoria, very concerned about scientific method, the Royal Society 1660, and how do we mesh what we consider to be science with Indigenous knowledge? It's a very interesting thing to do. And great necessity to be respectful of both approaches. It's a very very important area, because
in my view, from reading some of the material the Society in South Australia's got, it's not uncommon for Indigenous people to have stories about the creation of the landscape they live in.
No doubt.
And that applies around the world, not just Australia.
But they have quite a different time perspective than we do. Yeah. Now I'm looking for other questions if there are any. Do you have another question, Rod or Giselle or Ian even, that we might put to Sarah?
I have a slightly not contentious one, but one that I think I sort of reflect on a little bit in my work. You talk about the internal power of map making and the map maker, of the biases that they might put into their map, the perspective that they're trying to convey in their map. There's also a bit of a broader discussion in science about the role of scientists in communicating their research and their findings to the broader public, whether the role of science is to sort of advance scientific understanding for the community, or whether that is to have a say as well into some of the issues that their work might touch upon more broadly in society. Where do you feel you sit yourself, Sarah, in your work, and the way that you try and communicate? Obviously, you're here having this conversation with us about your book, and you're branching into that sort of more storytelling aspect of science communication. Is that a world that you find yourself quite drawn to?
Well, I do the storytelling side for a couple of reasons. One is that it's a labour of love for my students. certainly in the last 2 or 3 years, I've noticed their concentration spans have really waned. So one of my responses to that is to try and be more engaging. And if I go down the storytelling route, it stops me turning into a stand-up comedian at the front of the lecture theatre, which is the other thing I might do to try and keep their attention. But the other thing, and I don't know if this is just me, but I find every 5 years or so, as academics, we constantly write, and we'll be writing research papers. Every 5 years or so, I like to push out something that's a really big project that gets something off my chest. And this, for me, this book actually took me about, well, I started writing it before our kids were born, and one of them's now 13, so it's taken a long time to put together. But they're stories that I found really engaging, and they stuck with me, and I was just keen to compile them and get them out there as something that I thought was quite a compelling way to weave together the different types of work that I do. But really, in my this is just one component of my work. If I think about my life as a map maker, I tend to think that I've got some skills that are reasonably technical. I can make maps with drones or from satellite images and do some field work and maybe turn those maps into numerical models. That's actually still a very broadly applicable set of tools. And so what that actually has done for me in my career is given me the means to collaborate with people. So I might apply those skills in all sorts of different ways. One year it might be mapping a reef underwater, the next year it might be mapping seals or mapping worms in beaches. There's all sorts of different ways that you can apply. And, I've not really touched on many human geography applications of mapping as well, but there are plenty of those as well.
The big advantage of GIS skill sets, right?
Yeah.
I might bring the evening to a close now, if I may. Sarah, many thanks for sharing your knowledge with us tonight. You've made a fine Australian contribution to GeoNight 2026, the International Night of Geography. May I also thank our collaborators, the Royal Geographical Society of South Australia, the Royal Geographical Society of Queensland, Geography Victoria, and the Royal Society of Victoria. We're very, very grateful for your support for tonight, and we look forward to many more opportunities to share knowledge, thoughts, and ideas as geographers do. And of course, thank you to our audience for both your attendance and for your participation. Some great questions, and we hope we can see you all again soon. Good evening to you all.
Okay.
And thank you, Rob, for your great work in sharing the meeting tonight. Thank you.
No problem.
Thanks. I've really enjoyed
Thanks,
myself.
Thanks, everybody.
Fantastic presentation. Thank you, everyone.
Good night.
Good night.